Good evening, everyone. Thank you for signing on this evening to Rose Talks. If we've not met in person or virtually, my name is Brandon Zollner. I'm Executive Director of Alumni Relations at Rose-Hulman. My team is responsible for ensuring that our nearly 18,000 alumni across the world stay connected to Rose-Hulman. If you want to learn more about our office, you can always check out the alumni section on the Rose-Hulman webpage. That's rose-hulman.edu, and then click on the alumni and friends banner at the top. So our office is excited to bring some virtual content, especially during this pandemic, to our alums across the world. Rose Talks is driven by a desire from many of you who wish to hear more about faculty or alumni expertise within the Rose-Hulman family, if you will. Rose Talks is modeled after an internal speaker series we've had on campus for a number of years called Lightning Talks. These are bite-sized lectures. They're designed to both educate and stimulate the mind. They're modeled slightly after TED Talks, if you're familiar with those. Tonight's will be a little bit longer, though, because we have two professors teaming up to talk about chocolate. I have to say, this is one of our more popular Rose Talks that we've done to date. I think it has to do with the chocolate, has to do with the food, but also I think the science behind it is pretty fascinating. So I hope you'll enjoy it this evening. Rose Talks is pleased to present Dr. Kimberly Henthorn and Dr. David Henthorn this evening. Dr. Kimberly Henthorn, an alumna of chemical engineering from the class of 1999, specializes in particle technology and two-phase microfluidic systems and has worked with fellow faculty members to introduce new experiments to the chemical engineering lab. She's currently advising undergraduate students to research the science and engineering behind chocolate production. A member of Rose-Hulman's first co-ed freshman class, Dr. Henthorn is an alumna who has showcased her tap dancing skills in the Institute's annual Engineers for Concert. She's also an advisor for the campus Delta 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 sorority chapter. Her industry experience includes working for Dow Chemical and Riley Industries and serving as a consultant for Mosi Corporation, Brewer Science, and Pfizer. Dr. David Henthorn is an expert in biomaterials, biosensors, and polymers in medical application. His research focuses on 3D printing of biomaterials, and he is working with two fellow faculty members on a project to develop an electronic badge system to document students' professional development. Dr. Henthorn also advises the Chem E-Card Club, which is a student organization in which chemical engineering students design shoebox-sized cars that run on chemical energy from a chemical energy source. So without further ado, I will now turn this call over to Drs. Kimberly and David Henthorn, who will be presenting a Rose Talk titled The Science and Engineering of Chocolate.
All right. Well, we are super excited to be here tonight, and we were very overwhelmed with the response to this. We were hoping to have, a couple dozen people, and it seems like we had nearly 250 people that signed up for this talk. So we are really, really excited about this. Dave and I have been interested in the production of chocolate for about 15 years, and we've traveled around the country to a number of different facilities that make chocolate and gone on tours and whatnot. But it's only in the past couple years that we began making our own chocolate and seeing really how intricate and how technical it is to actually make a bar of chocolate. So as we've been studying this, we've been picking up a lot of knowledge along the way. And so we wanted to share that with you tonight because we thought it was kind of cool. So I wanted to give a shout out first. As I mentioned, there are about 250 people that signed up for this. And let me see if I can get this going. This is probably a picture that a lot of you guys have seen before. This was the first class of women to graduate from Rose-Hulman. So this picture was taken 21 years ago as we were getting ready to graduate. And when I looked at the attendee list, I was really excited to see 7 of the people in this picture had signed up. So I'm not going to name names, you know who you are, but it's really exciting to see us all come back together again. And to see so many familiar names on that list, from people that we've collaborated with on the alumni side, all the way to Dr. Haven, who is the family physician in the small town of 400 people that I grew up in, who he's also an alum. So we're really excited, and I feel like I'm among friends. So we're really, really excited to spend the next hour or so with you. So before we get too far into this, I wanted to make sure that everybody who had a chocolate sampling box has a chance to pull that out and to make sure that everything is where it needs to be. I've seen some pictures on social media, people as they've been getting their boxes and they're excited and showing pictures, but it looks like some of the ingredients had migrated around during shipping. So if you have a box, pull it out and make sure that the ingredients are situated as you see here. If you did get a box, you'll notice that there was this wonderful milk chocolate bar, a Theo bar at the top to sort of hold everything down. And this is not part of the tasting. This is a wonderful chocolate bar out of Seattle. I hear that the tour is excellent. And so it's on my bucket list someday when I get to travel again to go visit Theo. But this is a gift to you as a thank you for spending some time with us. So you can nibble on that or share it or whatever you want to do. The other thing that Brandon mentioned is, getting yourself some water and something neutral. If you do get water, if you could try to get something that's closer to room temperature, because if the water is too cold, then it tends to numb your taste buds. And then something neutral to cleanse your palate, not necessary, but kind of a nice touch. So, like a water cracker or a piece of bread or something. And fun fact, the International Chocolate Awards, their official palate cleanser is unseasoned, watered down polenta. So if you have any of that just laying around, you can certainly use that as well. Okay, so, and also those of you that didn't get a box, Dave and I assembled 100 of these and apparently they sold out fairly quickly. So I know that there's a number of you that wanted a box and couldn't get one. This presentation will be recorded and then posted later. So after you sit through the talk, you can make a list of all the stuff that we tasted and you can buy the stuff on your own and then go back and watch the video and redo the tasting if you want. Okay, so let me see. Okay, so I want to start from the beginning and we're going to just talk to you about how to make chocolate. And so obviously the first place to start is going to be with what ingredients go into making chocolate. And the most obvious place to start is cocoa beans, right? Pretty important in making chocolate. And so cocoa beans grow on cacao trees, and cacao trees really like humid, warm, rainy sort of climate. And so they like to grow about 20 degrees on either side of the equator in a band called the cocoa belt. And you can see that here. The top 5 producers of cocoa beans are labeled. You can see that 65% of the world's cocoa beans come from West Africa, and about 1/3 of the world's cocoa beans come from the Ivory Coast. So that's a really heavy producer of cocoa beans. Indonesia is also listed, but of course, Central and South America as well. So cacao trees look something like this. So if you look on the left-hand side, you'll see some really bright yellow and red and orange pods growing on the trunks of these trees. And so those are actually the pods. Those are not the cocoa beans themselves. And the color depends on the varietal of the cacao tree that you have, and then also the level of ripeness that you've got. But these pods are actually pretty big. If you look at the picture on the bottom left, you can see the relative size compared to a person. And most of these trees are grown in very rural areas, so a lot of the labor is done very manually by hand. So what happens is the pods are pulled off of the trees by hand, and they're broken open by machete or knife. And if you look at that center picture, you can see where someone has opened up one of the pods so that you can see what's on the inside. And each pod contains somewhere between 20 to 30 beans in there. And you can tell that they're covered in a white, sticky, pulpy material called baba. And that pulp contains water, acids, and relatively high levels of different sugars like glucose and fructose and sucrose. When those pods are broken open, then naturally occurring yeast and bacteria from outside the pod get in, and they come from, just the pod itself, from the workers' hands, insects, things flying around in the air. And actually that's good because that's key to the next step, which is fermentation. If you were just to eat one of these cocoa beans by themselves, they wouldn't taste like much. So you've got to do a little bit of chemistry. So what happens is these beans and the pulp are put into typically a wooden box, and they're piled up, and then they're covered with some sort of a natural covering. So in this case, you can see banana leaves just because that's very common and readily available there. And I'm going to show a plot because we all like plots, right? And so if you look at the top plot here, you can see qualitative amounts of the various critters that you might see inside of the box. So we've got different kinds of bacteria and yeasts. And the bottom plot shows the various components, the chemical components, and qualitatively how those change as well. Okay, so we start off with an anaerobic type of reaction just because that pulp is very sticky and doesn't allow a lot of oxygen to flow through. And so those sugars that are contained in the pulp combined with that acidic environment are ideal conditions for microorganisms to grow. So what ends up happening is that the yeasts begin to consume some of the simple sugars and they start making carbon dioxide, ethanol, and small amounts of heat. Then you have some bacteria that tend to produce lactic acid. Those are going to convert citric acid and glucose and other types of carbohydrates into lactic acid. And so what you physically see after a couple of days is carbon dioxide bubbles really bubbling up through that material. The other thing that happens is you have enzymes in there that will start to break down the pulp and turn it into a low viscosity liquid that begins to start draining away after a couple of days. And when that drains away, it also pulls off some of the citric acid, and that causes the pH of the system to begin to go up. And so when you remove that pulp, now you've got a lot of space between the beans and you start to get increased airflow. And so then you start switching over to the aerobic phase of the process. So now we've got an aerobic process. The workers will actually at this point start manually turning the beans to allow more oxygen into the system. So now we start to get domination by the acetic acid producing bacteria, and they are going to dominate. They're going to oxidize ethanol and acids into acetic acid, and then that acetic acid is further broken down into carbon dioxide and water. Now, the breakdown of ethanol is exothermic. So if you remember back from when you were in school, an exothermic reaction means that as the reaction proceeds, it's going to give off heat. And so the temperature inside this box can go from ambient temperatures to over 100 degrees Fahrenheit in just a couple of days. And so this is why these boxes get the nickname hot boxes, because they do get very warm on the inside, but they're not, heated by any sort of external source. So now that we've got a really hot environment, and we've got diffusion of ethanol and acetic acid, that's going to start breaking down the cell walls, and then the bean's going to die, and you're going to really get good development of the flavor there. So at this point, the beans are a nice bright red color, and they are spread out in the sun and allowed to dry. The fermentation step takes, roughly 6 to 10 days, depending on what kind of flavors they want to develop and what the climate is like. And the drying step then takes an additional 5 to 10 days on top of that. The moisture content in these beans goes from about 70% down to about 7% by the time they're done being dried. Okay, now at this point, after the beans are dried, they are ready to be packaged and shipped around the world, which is kind of neat, because if you look in your sample box, that bottom left section of your sample box, you should see 2 cocoa beans in there. Those are the stuff that we buy straight out of the drying rack that you just saw on the previous slide. So these are fermented and they are dried, but they are not roasted. I would highly recommend that you not pop these in your mouth for a couple of reasons. Number one is that they're not sterilized. These have been laying out in the sun, out in the middle of wherever they were grown. And there have been bugs and who knows what else going on them. So for that reason, you shouldn't eat them. But also, cocoa beans contain 50 to 55% cocoa butter in them. And so that's fat, and fat tends to go rancid if they're not stored properly. And over time, of course, that will begin to break down. And I'm not quite sure how old these beans are. We've had these around for a while, but if you hold them, depending on what conditions you hold them in, these types of beans can last, 9 months to a year or so before they start to not be very good anymore. So those are some cocoa beans. That's where we start when we start to make chocolate at home. Okay. At this point, then you've got to roast them. And the roasting, like I said, not only does it sterilize it, but it also helps to separate the meat of the bean from the husk. And you will lose additional moisture when you roast the beans. And so that helps to shrink the inside a little bit, and it makes the shell a little bit brittle. And so you can peel that off. And that process of peeling off that shell is called winnowing. And I don't know if they have Menards where you are, but we were at Menards last year and we saw cocoa bean mulch that you can buy for your garden. So, you don't want to waste things, and that becomes a nice little organic, natural mulch that you can use at home. But also the active roasting, you're going to have more chemistry. So the Maillard reaction and other types of cooking related reactions that you might see. So how do you roast? Well, this is our unit. This is a picture of the one that we use at home. This is a Baymore, actually it's a coffee roaster. So Dave also roasts coffee once or twice a week at home. And so this is a unit that we just bought online. It's a few $100. But you can roast about a couple pounds of cocoa beans in them as well. And it's programmable, so you can have different temperature ramps and things like that. You can stick the cocoa beans in the drum and stick it in the unit. We usually cook it at around 325 degrees Fahrenheit or so for about 18 to 20 minutes. If you don't have one of these units and you're interested in making your own chocolate, you can easily do this in an oven. So you can spread out the cocoa beans on a cookie sheet and stick them in your oven for 15 to 20 minutes, depending on how roasty you want them. 250 to 325 degrees Fahrenheit. It's really hard to mess it up unless you just char them, because different flavors will arise depending on how you roast them. And I have a quick little video, see if I can do this, to show you what it looks like. And so, you have a nice heat source in the back, and you can see the beans rotating on the inside, and you get a nice even roast that way. Okay. All right, so once the beans are roasted and you take all of the shells off, the inside, the meat of the bean can be crunched up pretty easily. And so what you're left with is what they call the nib. So if you've ever heard of a cocoa nib, that's what this is in this picture. And you can buy those to snack on. Sometimes they'll mix them into chocolate to add a little bit of crunch in your chocolate bar. But that is a cocoa nib. So that's the number one ingredient that you need in order to make chocolate. The next most important ingredient is going to be cocoa butter. Because as I mentioned before, cocoa beans are about half or so fat by weight, but that's not going to give enough fat for you to make a nice smooth emulsion out of it. You've got to add additional fat to it. And so you need to add additional cocoa butter. So where do you get cocoa butter? Well, you basically press the heck out of it. So you take the cocoa butter, and depending on, what your purpose is and the scale of what you're doing, in industry, they can apply up to 6,000 pounds of pressure to get the cocoa butter out. Some smaller places will get, 1,500 or so pounds of pressure that they apply. And what comes out is this. It's a nice yellowish but clear liquid that comes out. This unit on the right is called a NutriChef. We don't have one of these, but this is one of the very few, if not the only, home presses that you can use to get cocoa butter out of cocoa nibs. It's a couple $100, but we've not tried it. We just buy our cocoa butter from other places. And so what you get when you press it and you let it cool, you get this nice yellow, waxy sort of cocoa butter that comes out. And what's left over in the press, the solids, after you've removed all of the cocoa butter, is cocoa powder. And this is the same type of cocoa powder that you would use to bake with. So that's where they get, Hershey's cocoa powder or other types of cocoa powder. All right. If you look in your sample box, that little yellow disc is not white chocolate. So for those of you who tried to sneak a taste and thought this was white chocolate, you may have found yourself with a nasty little surprise. That is just straight up cocoa butter, just so that you can get a sense for maybe the texture of it. It's not going to hurt you to taste it, obviously, but it just tastes to me almost like lotion, I guess, a little bit, which actually, they do use cocoa butter in cosmetics and lotions and things like that as well, but that's cocoa butter. All right. And it wouldn't be a Rose-Hulman talk without a quiz, right? So I hope you guys are ready and hope you guys studied. So I'm going to let Dave do this.
Hi, everybody. I've been kind of lurking in the background, answering questions on chat and stuff like that. So along the way with the talk, if you have something, then jump in, ask me questions or something like that. But yeah, it's quiz time. It's professors talking, right? So we can't go too long without giving a quiz. So real quick, citizens of which country consume the most chocolate, and we'll do it per capita? So Ireland, Switzerland, Germany, or China, and you can answer at home or you can jump into the chat section. I'm seeing lots of Switzerland's. I saw one China bounce by. Germany. Haven't seen anything for Ireland yet. Okay. And so the answer is, it is indeed Switzerland, and it's about 10 kilograms, so 22 pounds of chocolate per person annually. The US comes in at about 10 kilograms, or 5 kilograms, so about half of that annually, whereas we put China on there, but China is the country that consumes the least chocolate amongst anyone in the world, at about 1/100th of that amount. So basically one candy bar per year, one chocolate bar per year kind of amount. So surprisingly little.
That's very sad. I can't imagine living on one chocolate bar a year. All right. Okay, back to business. All right, so we talked about cocoa beans. We talked about cocoa butter. The next thing is sugar. I love sweets, and so this is probably, to me, the most important ingredient. And there's really nothing special. If you're gonna make chocolate at home, there's nothing really special about the sugar unless you are vegan. So our departmental secretary is vegan, and we tried to make her some chocolate a couple of years ago for Christmas. And we realized that if you just open up a bag of regular old granulated sugar, that there's a really good chance that that's actually not vegan, because they refine it using bone char. So if you want to make a vegan chocolate, you have to make sure that you get something that hasn't used bone char in the refining process. So any sort of organic sugar, or sugar in the raw, something like that would work. And another major ingredient is milk powder. Again, you don't want to use this if you are trying to make a vegan chocolate, but you can use an alternative like soy milk, or our secretary really enjoys the taste of rice milk powder. And so, it adds a little bit of a different flavor to it. It's all really good. It just makes it taste a little bit different. One thing to watch: do not just pour liquid milk into your chocolate. So if you've ever tinkered with chocolate at home and you added a little bit of water in there inadvertently, you might have experienced seizing, which is where your chocolate just sort of clumps up and turns into a really disgusting mess. And that's because, as you see with the ingredients that we have here, it's very fat-based, and you've got a really nice emulsion at the end that has small particles that are coated in fat. Well, as soon as you introduce water into that, then you start to get segregation and you start to get clumping up, and it's really a really bad thing to see. Now, one thing I learned is that if your chocolate has seized up, you can fix it by adding more water to it. So if you add a lot of water to it, then that helps to smooth all of that out, and you can actually make a nice ganache out of that. So if you accidentally seize up your chocolate, just change course and make some ganache, and then try again with your chocolate bar. So these are the 4 ingredients. These are the main 4 that you need. And so what I want to talk about there are 3 major categories of chocolate. And so I want to talk about how the different ingredients come into play here. So my absolute favorite is milk chocolate. And milk chocolate needs all 4 of these ingredients to make it work. If you're going to make this at home, a really nice starting point, a base recipe, I guess, is equal amounts of each of the 4 of these ingredients by mass. And then, of course, once you've gotten used to it, you can tweak it and make it a little bit sweeter or less sweet or whatever. But for really good milk chocolate, you can't go wrong by doing equal amounts of these. Dark chocolate. If you want to go with a dark chocolate, you've got to remove one of these ingredients. Which one do you think it is? The answer to that is the milk. So if you take away the milk powder and you just deal with the cocoa beans and cocoa butter, and then sweeten it up with some sugar, then you've basically got yourself a dark chocolate. And so you can tinker with the different ratios. if you're going to make this. Just keep in mind, again, you've got to have a certain amount of fat for this to work. And remember that cocoa beans are about 50% fat. Cocoa butter is 100% fat. And so when you do the calculations, depending on what masses of the different ingredients you've got in there, you want to make sure that your overall fat content is at least 35%, because anything below that is going to be too viscous for you to really work with. So that's kind of how you can tweak your recipe. And then we've got white chocolate. And so which of these ingredients do you think needs to be removed in order to make white chocolate? I think this one's probably more obvious. It's going to be the thing that is brown, which is the cocoa beans. So to make a white chocolate, you're just going to mix up the cocoa butter with some sugar and milk powder. So it's still considered a chocolate because it is based out of the cocoa bean, right? The cocoa butter part of it. And that's really where it's going to get a lot of its flavor from. Okay. So if you're going to the store and you're going to pick out chocolate and you flip over and look at the ingredient list, don't be alarmed if you see a couple of these things, soy lecithin, or if you see natural flavors like vanilla or something else. Those are actually totally okay, and you can still, buy an excellent bar of chocolate with these. So the soy lecithin is really there just to help with the stability of the chocolate, and then the vanilla and stuff like that just helps enhance some of the other flavors that you see. So don't be alarmed if you see these extra things. At home, Dave and I don't use any of these. We just use the main 4 ingredients and go with that, and it makes a really good chocolate. We don't have to worry about stability because the chocolate doesn't last very long in our house when we make it. Okay, more quiz time. You ready? All right, Dave.
So this is going to lead into our first tasting. So what is the most expensive ingredient in chocolate? So we talked about the 4 ingredients that they go into sort of the high quality artisanal chocolates. So the solids and the butter, then sugar, then milk powder. So what do we think the most expensive ingredient is? So seeing a few cocoa solids and lots of cocoa butter answers. Yeah, so it's split in between cocoa solids and cocoa butter. So that's so far so good, yeah? Sugar is the cheapest. I'll give that answer away. So the answer is indeed the cocoa butter itself. Remember, we squeeze that out of the cocoa solids then and then collect that. And so that is going to be an important thing to remember when you do tastings and you look at the makeup of chocolate bars and stuff to see a list of ingredients and stuff.
Mm-hmm. And so since this is the most expensive ingredient in chocolate, there are companies who obviously want to reduce their cost, right? And so this is sort of the target ingredient. And so there's been a number of studies trying to figure out what can we use in place of cocoa butter and still have a chocolate that's edible and looks right. And so there's 3 main categories of things that you can switch out. So the first main category is what they call a cocoa butter substitute. And so a cocoa butter substitute are actually really common. So you might see palm oil or coconut oil in your list of ingredients. Those are cocoa butter substitutes. So those don't require tempering. We haven't talked about tempering yet, but it's basically a way of making sure that the crystalline structure is the most stable in your chocolate. So you don't need to do much except you mix up the stuff, and then, once it's molten, you just sort of let it cool down, and then you've got yourself a bar of chocolate. It's not compatible with cocoa butter, which means that if you wanted to bring in some of the cocoa butter flavor, you really shouldn't be mixing your substitutes with cocoa butter. The next step is a cocoa butter replacer. So again, these don't require tempering, but they are slightly compatible with cocoa butter. So you can blend cocoa butter with some of these replacers. So things like soybean oil, rapeseed oil, cottonseed oil, those are considered cocoa butter replacers. And then the last category is a cocoa butter equivalent. So these are, they have the same physical properties or pretty close to the same physical properties as cocoa butter. And so you can completely replace the cocoa butter with these equivalents, or you can blend them if you want to, but they do need to be tempered. And so things like ellip oil and shea butter and things like that are considered equivalents. Now, I will say that when I was tinkering around in the kitchen, I decided to find food grade shea butter, and I made a batch of chocolate with it, and it was totally not my thing. So I don't know if I did it wrong or if maybe I needed to blend it with some cocoa butter to make it taste better, but whatever it was that I made with the shea butter did not work for me at all. So I think that's why this is still an ongoing experiment.
And we just had a really great question. It was, the person was asking, why do we need to separate the cocoa into the butter and the powder? Like, why do you essentially need to augment with cocoa butter to make chocolate?
Well, the answer is that if you were just to have the cocoa beans and grind them up, they would not have enough fat in there to get the viscosity that you need and to get enough fat to coat all of the particles that will go into your mixture, because you're going to be having particles of cocoa solids, you're going to have sugar crystals, you're going to have potentially milk powder, and you need to make sure that all of those are very well coated in fat. And the cocoa beans themselves just don't have enough fat to do that. So you've got to add additional fat to get that fluid. So hopefully that answers that. Okay. All right, you ready to eat? Let's try something. Okay, so in your sample box, look at the two highlighted squares here. These are both dark chocolates, and we are looking for you guys to nibble on these. Don't nibble on them yet, but we're going to ask you which one of these two do you think is considered higher quality. So I'm not sure if you guys got these or not, but we had PDFs that we had sent out with this figure and this figure. And so these are tasting wheels and flavor wheels. So if you have those on hand, you can kind of refer to them as you're doing tasting. These are basically just adjectives and words to kind of help jog your senses into maybe describing what you're tasting and what you're feeling. So there is a difference between eating chocolate and tasting chocolate. I tend to just eat chocolate, gobble it up and stick it in my mouth and chew it up. But what we're going to try to do here is to behave, and we're going to try to taste this chocolate. And so what you really need to do is, take your chocolate, and on the right-hand side here, you will see 5 different sort of things to be thinking about. So look at the appearance of it. How are the colors different? Is it shiny? Do you see any white spots? What does it kind of look like when you look at one versus the other? And then instead of just sticking the whole thing in your mouth and chewing it up, take a little bite of it and feel whether or not you had a nice snap. Is it snappy when you bite into it, or does it kind of give, and is it kind of soft? And then again, don't just chew it up. Stick it on your tongue and sit there and wait and see what happens. So does it melt right away, or does it just sit there? Does it taste waxy when you finally chew it up? Is it very quick or very slow to dissolve? So those are the kinds of things to think about. And then once you do kind of chew it up, does it taste smooth, or can you taste a little grittiness in it? And then flavors, those are going to be really important. So when you have flavors, look at your flavor wheel, see what kind of flavors you get out of your chocolate, and then think about, are they sharp? Do they change? That's kind of important too. Like sometimes when you bite into a food and it has a certain flavor to it, after it sits there for a while, you get this aftertaste that changes into something totally different. So take your 2 chocolate samples and try them. Don't forget your water and your palate cleanser, and see, like, what do you think? Tell in the chat, what do you see? What do you taste? And I'll kind of flip back to here in case you don't have your wheel on you. I don't know if you can see this very well, but what do you sense?
I had a really interesting question that said that, we're splitting the cocoa into the butter and the powder. That doesn't seem like a sustainable ecosystem or economy then, since you keep needing more butter than powder. Just remember that cocoa powder is sold and then used in all sorts of baking goods and brownies and that kind of stuff. And if you've noticed that cocoa powder is not very expensive at the store either. So it's essentially a byproduct of that has its own market. And so that cocoa powder can go in that direction just fine. So we're getting comments then, the chocolate drops are creamy and melty, and the square is hard. And that's going to be an important part to pick up. Yep. So yeah, lots of adjectives of creamy for the dots, the circles, and then the square has a more honey-like taste to it. So we got that the square was bitter, a bit bitter, but good. We are having you taste dark chocolates first. We usually move in that direction. You go kind of like a wine tasting, right? You try the driest stuff first and then move towards sweeter stuff. And so that's the way your tasting is going to go tonight. The dark chocolates first, then the milks, and then we'll try some the special ruby and white chocolates last. So we had an adjective of waxy to describe the dots.
Okay.
With more roasty for the bar one. So if you have comments or complaints about the choice of chocolates, I did a lot of the running around trying to find what chocolate was available during this pandemic, because that actually ended up being somewhat difficult. A lot of chocolate manufacturers have had trouble getting product out the door. And so I was trying to find stuff that was going to be available mostly nationwide. So a lot of this comes from either supermarket brands that you can find, or from specialty stores that you can order online. Like some of the stuff came from Amazon, that kind of stuff. So we're trying to get you kind of a lower priced alternative versus a higher price, so you can taste them and see the difference between the two, but also stuff that should be available. So if you find something you like, you should be able to go to the store or order on Amazon or something like that. So yeah, waxy, another waxy descriptor for the dots.
Okay.
And a filmy remainder.
Yummy, that sounds great. All right. Well, I think in the interest of time, I'm going to go ahead and reveal what's going on here, if that's all right. So the top chocolate, Dave went down the street and bought these from Aldi. And these are dark chocolate that are made with sugar and cocoa beans and cocoa butter. The ones on the bottom are basically melting wafers. So there's no cocoa butter in those. What you're tasting in there is palm oil. So instead of the cocoa butter, you've got palm oil. So if you have a difference in taste that you're picking up on, it very well could be because of the difference in the fats. Okay. So, and I want to emphasize, I don't want to say which one's the best chocolate, because the best chocolate is the one that you think tastes the best. So sometimes I like a really cheap piece of chocolate. And to me, that's the best chocolate at the time. So just keep that in mind. Okay, let's move on. Oh, here, Dave, you want to talk about this real quick?
Sure. We've done a couple of these pairings at Rose-Hulman, and the executive chef there that runs, because we now have an executive chef for the dining halls and stuff like that. So think back to your years at Rose-Hulman, and did you actually have an executive chef that was like culinarily trained and everything like that? But Chef Justin then suggested some wine pairings when we would do this. And for these dark chocolates, they tend to be more on the dry side. So like a Pinot Noir or something like that. Our last chocolate tasting that had wine pairings, we served this La Crema Pinot out of California, for example.
Okay, great. All right, I'm going to try to step it up a little bit because I think we're running low on time. I've been chatting too much. Okay, so now that you've got all of your ingredients together, what do you do with them? Well, the first thing you need to do is what they call melanging, and then you need to do the conching. So what you need to do is take all of those particles that you've now put into your mix, and you need to break those down. What you don't want when you eat a piece of chocolate is to taste a bunch of grit. And your mouth can stop tasting grit at about particle sizes less than about 30 microns or so. So to give you some perspective, the diameter of a human hair is roughly about 100 microns. So 30 microns and below is where your tongue just can't discern individual particles. So you need to get the particle size down, and then you need to also refine it further. And so what you're doing is coating each of those particles with fat and also getting rid of some of those more volatile compounds. So what you see here is the home unit that Dave got for me a couple of years ago that we use at home. And I have this guy here. I don't know if you guys can see this, but this is the barrel that you see on top. And what it is it's a granite surface on the bottom and then a really heavy set of granite wheels like this. And these are very, very heavy. And so this will set down inside and they rotate and they basically just crunch everything up. And so, so here you can see from the top down, putting in the cocoa nibs. And then when you get all the ingredients in there and you get it going, it looks really gritty like this. So after a couple of hours, you kind of look at it. To me, it smells a little vinegary at first and you see it looking a little bit gritty, but then the magic happens and this is what you see. It's beautiful. And you want to let this sit for, you know, roughly 24 hours. Sometimes we've let ours go for up to 36 hours or so, because you want to make sure that everything is very, very refined and homogeneous. And that just looks wonderful. And your house will start to smell wonderful at this point. The temperature inside that melanger can get up to about 160 degrees Fahrenheit just because of the friction from the wheels rubbing up against the base there. And so the temperature in there actually gets relatively warm, even though there's not a heating element in there. And that's actually good because it helps keep everything fluid. Okay, so now we've got our chocolate. It's nice and fluid. What you don't want to do is ruin it by spreading it out on a table and letting it cool at room temperature. Because have you ever seen chocolate that looks like this with the white film on it? A lot of people think that that's mold, and it's actually not mold. It's actually what we call bloom. So chocolate is an unstable mixture, right? It's a bunch of particles suspended in fat, and you mix it all up. And then when you let it solidify, you've got crystals that form and lock in the structure. And what we want to do is to make sure that the crystals that we lock in are the most stable kind. So I'm going to do a really quick material science lecture here. I've only taught material science a couple times, so we'll see how good I do. But basically, cocoa butter has 6 different polymorphs, crystalline structures that it can solidify into, and they are called types 1 through 6. And you can see in this table here that the melting points are different depending on what type they've got. The ideal crystal structure that you want is type 5. That's the one that's going to be the most stable and has the best properties that we like to have. So what you would like to have is a chocolate with all type 5 crystals. So how do you do that? Well, if I set the temperature there where that blue arrow is, on the left-hand side is supposed to be like a container with my chocolate in it. At that temperature, somewhere above 78 degrees, but below 81 degrees, you can see that all the types 1, 2, and 3 crystals have melted out. And so we would anticipate seeing types 4, 5, and 6, and those would be readily formed at that temperature. Now, if I raise the temperature just a little bit after shearing it, then those type 4s will disappear. And so holding it at this temperature and keeping it in a shear by stirring it quite a bit, you can actually get those 5s to grow because those are going to grow fairly quickly. And then when you begin to cool it down, you've got seeds of type 5 crystals all over, and then they will eventually hopefully solidify into something that's mostly type 5. Now, depending on which type of chocolate you're working with, those main temperatures that you are looking for are going to be different. So as you can see here, we're assuming that we have some sort of untempered solid chocolate. And what you want to do here is raise the temperature up to erase any sort of crystals that have already formed. And so depending on the ingredients, that temperature might be different. Okay. Then what you want to do is bring it back down to the point where I started on that previous slide. So somewhere where the 1, 2s, and 3s are melted out and the 4s, 5s, and 6s will begin to grow a little bit. Once you've got that established, you raise the temperature up slightly to get rid of those 4s, and you hold it there and shear it and hope that you can get a lot of the type 5 crystals to begin to seed out, and then you can cool it down. Okay. So if you look at types 1 through 4, those are called beta prime crystals. Those are unstable. So if you have those in your chocolate and you let it solidify over time, and this can take a couple of hours to a couple of weeks, those crystals will reorient themselves and actually form type 5, which is good. But in the process, the cocoa butter will begin to migrate and be pushed up to the surface. And that's what you're seeing when you see that chocolate, that fat bloom up at the top. You can also see bloom if you've done everything perfect and everything's tempered, and then you let it just cool at ambient temperature, because we have something called a latent heat of crystallization. So if you do a phase change, you're going to be releasing some energy when you go from a liquid to a solid state. And so if you have that phase change and the temperature above the chocolate is not kept cool, you can actually get a pretty hot layer there at the top that will make your chocolate go out of temper. And then when it cools, then you'll get the type 3, type 4 crystals to form there. So ideally, once you've got everything mixed and tempered and ready to go and you spread it out, you want to make sure that you're holding it in a condition where it's about 10 degrees less than ambient so that it pulls that latent heat of crystallization off so you don't ruin the surface. The other thing I want to mention is, why do you want to temper? Well, besides the fact that it's ugly when it's not tempered, is if you've ever gone to one of those gourmet chocolate shops and you see just how shiny those truffles are, the shininess shows that you've got really good temper. So a really shiny surface is indicative of good temper. You also get good snap, where when you bite into it, it's just really crispy. You've got nice even color, and good contraction is important because as it solidifies, it'll pull away from the sides of the mold so that when you flip the mold over, the chocolates just pop right out. Okay, The other type of bloom that you might see is sugar bloom. It looks similar to what you would see with a fat bloom, but it comes from the sugar. So if you store chocolate, let's say in the freezer, and then you just put it out on your counter and then it begins to thaw, you'll see some condensation occurring on the surface. Or if you're storing it in a high humidity environment, you'll see some droplets on the surface. And then what happens is that the sugar that's there will dissolve. And then when the water evaporates, the sugar will recrystallize and you'll get little crystals of sugar on top. So if you are seeing problems with bloom and you're not sure which kind you have, you can just rub a wet finger across the surface of it. And if it feels waxy, it's fat bloom. And if it feels a little bit crunchy, that's sugar bloom. So that can help you to troubleshoot what you're doing wrong with it. And I want to say that if you do have chocolate that looks like this, it's not ruined. You're not going to die. It'll still taste great. The texture might be off a little bit, but you can always melt it down and retemper it with no problem. Okay. Next. All right, next chocolate trial. Ooh, we're running low on time. Okay, milk chocolate trial. So now we've got 2 milk chocolates here. And now, again, not which one's better, but which one do you think is more expensive? So do the same sort of exercise that we just did. Don't gobble it down. Take little bites of it. Think about flavors and textures and all of that and see what you think.
So we had a question or a comment then about, do the little hexagon ones have fat bloom on them? They're actually packaged, designed to be melted by a professional baker or a chocolatier. And so they're actually just scuffed. They rubbed against each other in the package. We just bought them in bulk. And so they do kind of look like they might have bloom on them. But in this case, they're just scuffed from rubbing against each other.
That's a good question. You can tell just by looking at it that there's a color difference as well.
But that is a good comment that I'm seeing in the chat about the hexes melting on contact with your fingers. That's an indicator that it's not as tempered as you'd expect, since the tempering temperature is right around, not body temperature, but skin temperature. So people are saying that they're tasting, it's more gritty or granular of the hex ones. They're also getting some caramel notes in the hex ones. We have a guess that the square has a higher cocoa butter content. The square is glossy and uniform. It's got a weird aftertaste. That's a little bit plasticky. Yeah. The hexagon one is caramel forward and the square is smoother. Eric Anders at the end here said he's guessing that the hex one is more expensive.
Hey, Eric, you get an A+. I'll go back and change whatever grade you want. But yes, the hexagon one, the Cho chocolate is about $1.50 an ounce, whereas the bottom one is a Shogetten chocolate. It's about 28 cents an ounce. Both of them still have the cocoa butter, cocoa beans, the sugar, and all of that. So they have the same ingredients. There's no substitution with the cocoa butter, but the top one is actually quite a bit more expensive. So yes, very good.
Yeah, in terms of like dollar per bar, the Cho chocolate runs in the $3 to $4 range, whereas the Shogetten one, the square one, runs in the just under $2 kind of range. We chose the Cho one, the hexagon one, as like baking. They would sell those as squares to chocolatiers. It's the same formulation as their bar, but in this case, it made it a little bit more deceptive what it really was, whereas a $4 a bar chocolate bar.
Okay, wonderful. Okay, and then the wine pairing?
Yeah, again, this is what Chef Justin chose here, is a Cabernet Sauvignon. I think some of the comments in the chats were, you know, the drier wines are kind of difficult to pair with chocolate, and I kind of agree with that. But that was what Chef Justin had chosen for our wine to pair with the milk chocolate.
All right. Okay, so I just want to really quickly talk about percent cocoa. So you can see here in the background, we have 3 different bars from Scharfenberger, and this is one of my favorite chocolates. It used to be out in the Bay Area, and Dave and I went and visited about 15 years ago and saw their facility. And then a few years ago, we were wondering whatever happened to Scharfenberger because we hadn't seen it for a while. And come to find out, they moved to Robinson, Illinois, like less than an hour away from Terre Haute, because they were bought up by Hershey. So we had a Rose alum who I think he's out there now. Hey, Nathan. And he got us hooked up with some of the people at the Robinson facility, and we were able to go and look at the Scharfenberger facility there in Robinson. So anyway, so that's the Scharfenberger line. And you can see at the top, they have different percentages of cacao out here. And at the bottom, you can see then that this is considered extra dark versus bittersweet versus semi-sweet. So what does it mean by percent cocoa? Well, these are dark chocolates here, and percent cocoa just means what is the percentage by weight of the total chocolate that comes from cocoa products. So the cocoa solids, whether that's nibs or the powder that you're using, and cocoa butter. So for a dark chocolate, for example, here we have a Cho chocolate that's a 70% dark chocolate. What that means is 30% by weight has to be sugar, since we only have the 3 ingredients in a dark chocolate. The other 70% comes from some ratio of cocoa solids and cocoa butter.
And earlier in the chat, we had a question. They've heard about the health benefits of chocolate. And so we actually have this slide here, which is great. Cacao is loaded with antioxidants in the form of what we call flavanols. We have a chemical structure, since we're all chemical engineers here. We like this kind of stuff. And those flavanols are really interesting because the antioxidant properties do all sorts of, they're a great way to protect your cells against oxidative damage. They're kind of interesting in that they've also had clinical trials or clinical studies that show that they lower blood pressure. And the fascinating thing is that it gets more effective the older you are, the better you respond to the chocolate. Now, to get this, though, you need to choose high cocoa percentage dark chocolates typically. So the higher the cocoa percentages, the more flavanols and antioxidants you're going to have. Now, we will put a caveat in there that chocolates contain saturated fats and significant calories, so don't just change your diet to all chocolate. At the bottom there, we do have a link to, there's a very nice Harvard website, Harvard Medical School website that talks about the health benefits of dark chocolate. So bounce over there for some good reading. Now, again, chemical engineering here. So I have 2 molecules on the screen, and I'd be impressed if anybody could just look at those 2 things and see what they are, because they're cousins. And they're actually different by one little group, which in this case, there's a hydrogen versus a methyl group. Yep, so the cursor's over there by the hydrogen group versus the methyl group. And the surprising thing is that these 2 chemicals, or these 2 molecules, are very close together. And I guess next slide will reveal them. So the scientific name for chocolate, or for the cocoa, is theobroma cacao. Theobroma meaning like food of the gods kind of thing here. And so the main molecule that you, or one of the main molecules that you'll see in chocolate is theobromine. And for the longest time, I thought that there must be bromine then, that the atom or the element bromine in chocolate, but it's not. It's just the name of the chocolate deriving from theobroma cacao, the scientific name. If you notice, theobromine and caffeine are really, really similar. And so you get people getting really interesting questions about, like, are there neurostimulative effects of chocolate similar to the way caffeine stimulates you? And that methyl group makes a huge difference, though. And so you don't have, if you eat chocolate, you're not going to have the neurostimulative effects. You're not going to be able to, or it's not going to prevent you from going to sleep or anything like that. It is orders of magnitude lower than caffeine and how much it acts as a stimulant. So no big deal there. And then we've got in the chat section, I guess, the IUPAC names for these molecules. I'll just take your word for it.
Okay, now I want to talk about one last thing that I find very interesting, and then I'll be quiet. So if you remember when we talked about milk chocolate, we had these 4 ingredients here. Well, there's actually a 4th type of chocolate that's starting to come on the market here. In the US, FDA doesn't recognize it yet as a type of chocolate, but some other parts of the world are starting to, and you can actually start to buy this here in the US now. And so what happens is the Barry Callebaut company kind of has this under wraps, and they said that they've discovered this 4th type of chocolate. But what we do know is that during the fermentation process of the beans, where they turn bright red after a few days and they get really sour, what we think they're doing is they're grabbing the beans after they've only fermented for a few days, and they throw some acid onto it, and they lock in that bright red color that normally would fade in the drying process. And they also lock in the sour flavor. And so now what you've got are these normally brown cocoa beans that are red. And when you process those red cocoa beans with the other ingredients that would go into a milk chocolate, you no longer have milk chocolate, you have what they call ruby chocolate. And it is really cool. Here's a picture of ruby chocolate straight off the Berry Callebaut Company page. And look at how pink that is. There is no colorant in there at all. That red color comes from the natural color from that fermentation that they've stopped in the beans. Like I said, there are some places now that are starting to make products of it. This is a picture that actually one of my sorority sisters, who I don't think she's on here tonight, but she got these out of Canada. These are Kit Kats made with ruby cocoa beans. We just finished watching the latest season of Great British Baking Show, and one of the contestants there was using ruby cocoa as well. So what we have for you, I don't know how many of you have ever tried ruby before, but in this last square, we have nothing to compare, but here's some white chocolate just because it tastes really good. And then here are a few chips of ruby. And as you taste those ruby chips, just remember that there's no added flavors to it. It's the exact same formula as what you saw with the milk chocolate, but see how different that taste is. And I'm interested to see what kind of flavors you're picking up.
So comments on tasting it. The ruby has a sour finish. It's like an aged lambic. Yeah, interesting.
Yeah.
The ruby is so fruity.
Yes.
I believe they actually add citric acid to this, though.
To the ones that they have here, or to ruby chocolate in general?
I believe these chips have citric acid in them.
Oh, do they? Okay.
So you're going to pick up a little bit extra fruitiness or citric kind of flavor to it.
And you know, if you guys are looking for these to eat, you can get these off of Amazon, but also Trader Joe's was selling these for a while. I don't know if they still have them or not, but we had picked up some at Trader Joe's before.
They are starting to show up in grocery stores as a ruby chocolate bar you can get now.
I think it's fascinating to me, just the taste of it. To me, I taste a lot of raspberry and strawberry and things like that.
So we've had good luck turning that ruby chocolate into a ganache. So that's like a chocolate water sugar mixture, and then filling other chocolates with it. And so you get usually like a dark chocolate. So you go for like a dark chocolate, you break through the shell, and then it goes into the fruity flavor as the filling for the chocolate.
So good. Dave's really good at making filled chocolates.
Is there a Trader Joe's in Terre Haute? No. There is an Aldi. And so if you haven't noticed, Aldi's a pretty decent place to go. Aldi and Trader Joe are kind of related through Aldi companies in Germany. There's an interesting history there between the brothers that formed Aldi. And so you can kind of get some of the same stuff at Aldi. Yeah, and so you kind of lean into the full sweetness of these and go with something like a sweet rosé or something like that. This is the wine pairing that we had at our last chocolate tasting with whites and stuff. So yeah, we've had great success with spinning up some of these food projects on campus. One of these things we did, for example, and I'm going to have a shout out to Owen, who's on the line, it seems right now. We wanted to have students experiment with things as early as possible in their career. So they do an intro to design class where you go in and you try to come up with some process and some new thing and show that you can use your engineering skills, your science skills then to kind of create something. And over the years, we've had all sorts of crazy things, and you're always worried in a chemistry lab, like, are they doing something that's going to blow something up or something like that? But food, people have an innate knowledge of, and so they can like be really creative with food. So apply engineering principles to food, and there's this deep emotional connection to food as well. And so we've had really great luck with teaching through food projects. So in the case of Owen's project, we threw a video to them and said, here is someone trying to 3D print chocolate. Can we do a better job as Rose-Hulman engineers? Can we make a better 3D printer, or can we make a better formulation of chocolate to do 3D printing? And sure enough, they went off and they researched it, and it gave me a chance to introduce like these more complicated fluid dynamics, things like non-Newtonian fluids. So chocolate in the melt state is a non-Newtonian fluid. Allowed me to introduce these different concepts through a very familiar media of food. And I was expecting them to kind of come up with a chocolate formulation, show that maybe with a syringe you could kind of mimic 3D printing or something like that. But Owen instead just goes back to his dorm room and builds a 3D printer in his dorm room that can print chocolate and stuff like that. So shout out to Owen if you're still on the line. These food projects on campus have been very multidisciplinary. Of course, chemical engineering is involved, biomed and biology, But people from any electrical computer engineering, we've been doing some controls projects. How do you control, in this case, it's been coffee roasting. How do you control a coffee roaster to get the perfect coffee roast or the perfect coffee brewing? And so we're doing that with people in electrical engineering and math as well. And the people in chemistry have their projects. We've been using this to do sort of outreach programs. Kim has been doing some summer camps where they reach out and they do some different things, including like encapsulation for like, if you think like bobas or molecular gastronomy kind of encapsulations, it's a cool thing to do to talk to middle school and high school kids. So we've been working more and more of this into our undergraduate education and curriculum. Design project lab classes, we spin up independent study projects. And so this has been a really great thing that we've added to our curriculum. It's also been a great way for us to bring up some industrial collaborations. So we have on the chocolate side, Kim's mentioned, talking with Hershey's and stuff like that. And I can't complain that we've also been collaborating with breweries and distilleries throughout the US as well. That's been a cool aspect of it. So all these things have been kind of done in little corners and different places. We're really excited that the campus is getting a new academic building. And in that new academic building, you can see there at the top floor, there's those 5 windows there. That is going to be the new food lab. It's under construction still, but if you want to show the under construction picture, yep. So there's those 5 windows looking out. That's looking out towards fraternities. Mm-hmm. And so it's looking out there. And so this is going to be a great space where we say, all the normal chemistry lab rules that you can't have food or anything like that, they get pushed aside. And so we do a very careful space that's dedicated to having the ability to create new foods and try them and work with. We have projects in coffee and chocolate and probably some fermentation stuff. I know people have been talking about kimchi and stuff like that as well. So let's see. Oh yeah. So
that's it. I know we've went way over time and I apologize for that, but we are really excited that those of you guys that are still here hung on with us. And please email us if you have any questions or have any suggestions for us or want to follow up with anything. There's our contact information right there. So we really appreciate your time tonight. And I had fun. I hope you guys did too. And hopefully you learned something during the process.
Yeah, so those of you that didn't have the chocolate boxes, what we would recommend is going out and finding, a milk chocolate that's $1 a bar and a milk chocolate that's about $3 or $4 a bar. Compare them, look at the snap, see if you can determine which one has a better temper on it, but then also the graininess, how refined it is and that kind of stuff. And so maybe pick some darks in the $1 range or $2 range versus a $4 range. And you could kind of recreate what we did here tonight with your own stuff if you wanted to.
Well, thank you, Dr. Kim Henthorn, Dr. David Henthorn, for the really engaging talk, the tasty talk, if you will, about chocolate. Very exciting. Please feel free they shared their contact information with you, so feel free to reach out to them afterwards. They're happy to answer any questions. And be on the lookout for future information about the new food lab as more of that information rolls out and about expansion of some of the curriculum with chemical engineering and some of the lab projects and things. I'm sure we'll be advertising some of that through our alumni magazine and through the alumni website. You can view this talk as well as past Rose talks on the alumni section of the webpage. So if you want to go back, buy some more chocolate, have a couple more friends over and relive this tasting, you're welcome to do that. It usually gets posted in about a week after we do a little bit of editing to it. Always be sure to follow Rose-Hulman Alumni Network on our social media channels, Facebook, Twitter, Instagram, and LinkedIn, or you can contact us directly at all one word alumni relations at rose-hulman.edu. We do plan on doing Rose Talks for the foreseeable future. So our next one is scheduled for January 21st. It will feature Professor of Electrical and Computer Engineering, Dr. Wayne Padgett. He's going to speak about personal cybersecurity. And then we're also going to have Assistant Athletic Director for Sports Information, Kevin Lanke. He's also an alum, giving a spring athletics preview. So with COVID and the pandemic, not all of our fall sports, but a lot of our fall sports through the conference was pushed back to the spring. And Kevin's going to give an update on how we're going to go about that and some of the things to look for during Rose's athletic season coming up this spring. So thank you again for signing on. Thank you, Dr. Henthorn, for this exciting and intriguing talk. And with that, we'll shut the meeting down. Thanks for signing in, and forever Rose.